Okay, in this video I'm just going to give you the solutions for the question 3 in tutorial 7, which is about the how are going to use the first law of thermodynamics in open systems. So first of all, when we read this equation again, I'm just going to recommend you that you make a quick list of all the information inside here. Okay, so a gas, so we know that the working fluid is a gas now, and the mass flow rate, m dot, so that's a kilogram per second. So I'm going to write here m dot 2.5 kilogram per second. Okay, enters a nozzle, so that's a nozzle. Okay, so we introduced some background knowledge about nozzle, so you know the basic, most important function of a nozzle is just to increase the velocity of the gas. Okay, and then there's no work transfer, no heat transfer, with negligible velocity. So negligible velocity means that the inlet, okay, so when we're talking about enters a nozzle, so everything here is about inlet. So negligible velocity means that C1 is about 0. Okay, and the inlet specific enthalpy H1, so that's H1. Okay, 3053.2 kilojoule per kilogram, right? And leaves nozzle, so every parameter followed by the sentence leaves nozzle shows anything about at the outlet, so the velocity of outlet. So we use 2, subscript 2 for anything about outlet. 505 meter second. Again, now we can neglecting change in heat transfer. Okay, so the heat transfer can be ignored. Okay, and also the potential energy. Okay, the change in the potential energy. So delta P dot E dot is 0 as well. Now we need to calculate. So we need to calculate specific enthalpy. So that's H, lowercase, specific enthalpy at the outlet. So we need to calculate H2. Okay. And the area at outlet. Area at outlet. So you can see here, so you need to provide an answer in centimeter squared if the specific volume at outlet, again outlet specific volume, so we use a V2. Okay, V2, if we know that V2. Okay, so we're going to solve the first one, H2. Okay, so in the formula sheet, if we are not sure about how to simplify that equation, we can do it again. So this equation applies to any open system for any device. Okay, so we have a long equation. And now, first of all, you can just copy that long equation down first of all, and then we have a look. So this is a change in kinetic energy, okay, plus a change in potential energy. So that's a long equation which you can copy directly from that formula sheet. And now we know the change in the potential energy here. Change in potential energy is 0, so just cross that out. Okay, and the heat transfer is 0. We cross that out. And think about the work transfer, right? So actually, in all the 6 devices we have learned from the lecture, only the turbine and also the compressor has got shaft work. All the other devices, they are not able to provide any work, so they're not outputting any work, and also you don't need to input work for that device to be working, which means that the work transfer is 0 for the nozzle, because the nozzle is used mainly to increase air velocity, so the work is 0. So on the left hand side, we got both terms as 0. Okay, so that's why we can actually divide m dot on both sides as well. So 0 divided by m dot will still got 0, and m dot here can be deleted as well. So now we just got here, so this has to be 0. Okay, so this is how we simplify the first law of thermodynamics according to different devices based on different assumptions. So this is one way you can, write a simplified form for this nozzle by yourself. Okay. Also, if you think that's easier, you can also use the teaching material in the next slides. If you still remember that table, I summarized all the simplified form for each of these devices, so you can just copy that down as well. So it all depends on you. Okay, so here we've got the simplified form of that equation, and then we just need to calculate H2 now. Okay, so H2 is equal to, so I'm going to move H1 over there. This one over there too. Okay. So H1, we actually know H1. H1 is here. So it's 3053.2. Subtract. So you need to check the unit again. Okay. So this is a kilojoule per kilogram. Okay. Kilojoules. Subtract half C2 squared. So C2 is here, 505 meter per second. And C1 is 0. Okay, so we just actually here we just times, because C1 is 0, we times 505 squared. Okay, so here this is a very common mistake here. It's very easy to be ignored, this mistake. This is because meter per second, so this is velocity. C2 here is in meter per second. Okay, so meter per second is actually a perfect, SI-based unit, because meter second. However, kilojoule is not, right? So you have two options here. You can either times this by 1000 to convert a kilojoule to joule, or you can keep that. However, you divide this by 1000, which I recommended here. Okay. It's because if we times that by 1000, you will get quite a big number. So if I divide this by 1000, this will make sure that the final answer for the H2 will also be in the same unit of that. So it must be kilojoule per kilogram as well. Okay, so this part divided by 1000 here is a very common mistake. So you need to be very careful about that. Okay, so now if you calculate that, you will get the final answer is about 2925.69 kilojoule per kilogram. So that's for the H2, the first equation, first question. Okay, so I give it 1 here. Right, now we're going to calculate the second. So second question is again about the outlet area. Okay, and then if we know the specific volume at C2. So this is again, we're going to use a formula sheet here. Okay, this is the formula sheet. The last equation actually. The last equation, mass flow rate is equal to m dot. M dot is equal to A times C, velocity over specific volume. So first of all, I'm just going to copy that equation here, formula here. Okay, so m is AC over V. Okay, because we're looking at A2 here, so we're looking at anything about at outlet. So I'm going to put the subscript of 2 over here. Right. So we're looking at A2 now. A2. So just going to rearrange it. Okay, I can multiply V2 on both sides, and then I will divide C2 on both sides. So we'll get A2. Okay, m dot. So m dot is here, 2.5 kilogram per second. So that's 2.5 times V2. Okay, so V2 has been given here. So both of these are in SI base unit already. C2. Okay, so C2 is a velocity at an outlet. We have it here. Okay, 505. Right, so then we just calculate, because we're using SI base unit for each of these terms, so the final answer will be SI base unit as well, which is 4.47 times. Okay, as I said, you definitely will get SI base unit for the area, which is a meter squared. And also, don't forget that in the question you're asked to calculate, to give the answer in centimeter squared. Okay, so we just need to do a little bit of conversion here by 10 times 10 to the power of 4. So these will be cancelled. And finally, you will get 7.747 centimeter squared. So that's the outlet area in the unit of centimeter squared. Okay.